In class, we discovered two different ways to figure out what the result was of composing a rotation and a flip or reflection. Let's look at both. The first is to draw two copies and just do it. Let's start with a rotation of 3. That will bring 0 to 1 to 2 to 3. So we know this has brought us all the way to 3. Next, we'll do a flip over the line at 0. So this is flip 0. And we can see that what this gave us is something that maps 0 to 2. 1 stays at 1. 2 goes to 0. 3 goes to 4. And 4 goes to 3. So if we can figure out whether this is a rotation or a flip, we're done. Our second method was to write out which vertices, which points, ended up at which points. So let's do that rotation again. 0 rotates around to 3, and now we can write this down. 0 goes to 3, 1 goes to 4, 2 goes to 0, 3 goes to 1, and 4 goes to 2. We now know that this rotation, a rotation of 3, takes 0 to 3, 1 to 4, and so forth. We will now figure out the correct pairings for flip 0. That's the flip over this vertical line. We can see that 0 remains at 0. 1, however, ends up over here at 4. 2 ends up at 3, down here. 3 ends up at 2, and 4 ends up at 1. So flip 0 moves 0 to 0, 1 to 4, 2 to 3, and so forth. Now that we have written rotate 3, flip 0, we can combine them. 0 is mapped to 3 by the rotation, and 3 is mapped to 2 by the flip. So in the combination, 0 is mapped to 2. 1 is mapped to 4 by the rotation. 4 is mapped back to 1 by the flip, so 1 is mapped to 1. 2 is mapped to 0 by the rotation, and 0 stays at 0 in the flip, so 2 is mapped to 0. 3 is mapped to 1 by the rotation, and 1 is mapped to 4 by the flip, so 3 is mapped to 4 by the combination. 4 is mapped to 2 by the rotation, and 2 is mapped to 3 by the flip, so 4 is mapped to 3 by the combination. So here we have discovered that the combination of rotate 3, flip over the 0 line is 0 to 2, 1 to 1, 2 to 0, 3 to 4, 4 to 3. We just need to figure out which rotation or flip this is.